In today's lesson, we're going to build the unit circle, and I'm going to show you how all of these parts come to be on this unit circle. We've got degree measures, radian measures, and we've got coordinates on this unit circle. So first, how do we show measure on the unit circle? We can show measure in degrees. So I've got this unit circle here, this center point. If I put this on the coordinate plane, we'll locate the center point at the origin. So that center point's at 0, 0. I'm going to draw my two axes, my vertical axis and my horizontal axis. And the radius of this unit circle is 1. So the distance from the center point to any point on this circle is 1 unit. So we know that a circle is made up of 360 degrees. So from this center point, if I go out to the right on this x-axis, that measure is 0 degrees. If I go halfway around, going in the order that we name our quadrants, quadrant 1, 2, 3, 4. So if we go counterclockwise, we'll find that 360 degrees. If we go halfway around, we'll be at 180 degrees, right? So the entire circle is made up of 360 degrees, which means half of it is made up of 180 degrees, which means a quarter of it is 90 degrees. So there's 90, 180, add another 90 to get 270. So those are our angle measures. Now, if I bisect each of these quadrants, if you will, so these 90-degree angles, I'm going to bisect those. That means split them in half, which means in this first quadrant right here, if I split 90 degrees in half from my x-axis up, that measure is 45 degrees. Another 45 degrees makes 90. Another 45 degrees makes 135. Then I've got 180, then 225, 270, 315, and back to 360. What I'm going to do now is I'm not bisecting those 45-degree angles, but what I've done is I've split this entire circle into 12 equal parts. If I divide 360 by 12, I get 30. So that's what we're going to count by. We're going to count by 30 degrees on the green lines, right? Those angle measures. So from my origin out, like toward on my x-axis to the right, that's where I'm going to be. When I go up, that makes 30 degrees. To the next green line, when I add 30 more, that's 60 degrees. 30 more makes 90. 30 more makes 120. 30 more makes 150. Then I get 180. 30 more makes 210. 30 more makes 240. Then 270. 30 more makes 300. 30 more makes 330. And then a full rotation around our unit circle makes 360 degrees. So that's how we show degrees on our unit circle. That's how all of those degree measures come to be. So now let's break this out in radians. We've got our circle. We'll draw our axes. And we know from the center out to the right, that's how we start. We go with 0. Now, I want to remind you that all the way around my unit circle, it's made up of 2 pi. So recall that a radian is the arc length. So the length, 1 radian, is equal to the arc length when the radius, if the radius is 1 right here, radius is 1 right here, 1 radian would be the length of that arc. That's 1 radian. Recall that the circumference of a circle is 2 pi r. If my radius is 1, then the circumference of that circle is 2 pi. So that's how we measure in radians. All the way around is 2 pi, which means halfway around is just pi. So what I really like to do when I'm breaking down radians is I focus on the semicircle, okay? So this semicircle is pi because the entire thing is 2 pi, and sometimes that confuses students. So let's look at the semicircle. If this is pi, then half of that would be 1/2 pi, which is pi over 2. I'm going to go around. So I'm going to actually count by 2's when I'm talking about fractions. Pi over 2, Here would be 2 pi over 2, which simplifies to pi. Down here would be 3 pi over 2, and then 4 pi over 2 simplifies to 2 pi. So let's bisect those angles. And now what we've done is we have split this whole circle into eighths, which means our semicircle, half of our circle, is split into fourths. Since half of the circle is pi, we're going to count by fourths. So when I count by fourths, I get pi over 4, 2 pi over 4, which simplifies to pi over 2, 3 pi over 4, 4 pi over 4 simplifies to pi, 5 pi over 4, 6 pi over 4 simplifies to 3 pi over 2, 7 pi over 4, 8 pi over 4 simplifies to 2 pi. Now what I'm going to do is I'm drawing my green lines, okay, which we know that those counted in, 30-degree angle measures when we talked about degrees. But when we're talking about pi, we have split this up into 12 equal parts, which means half of my circle is split into 6 equal parts. So I like to focus on that because that's kind of what we count by when we're talking about fractions, right? Because half of the circle is pi. So let's count in fraction form, going up with half the circle, right? So like these fractional parts, meaning this angle right here is pi over 6. This is, go to the next green line, 2 pi over 6, which simplifies to pi over 3. 3 pi over 6 simplifies to pi over 2. 4 pi over 6 simplifies to 2 pi over 3. Here's 5 pi over 6. 6 pi over 6 simplifies to pi. 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. 11 pi over 6 is right here. So that's how we get all of our radian measures on our unit circle. When I put the degrees and radians together on the unit circle, it looks like this. But that's how we build this unit circle. That's how we can show measure on our unit circle in both degrees and radians. And it's really important to, when you're talking about trigonometry, you'll see degrees and you'll see radians, and it's important to note the difference, okay? All right, so let's move on. How do we determine the coordinates on the unit circle? So the coordinates on the unit circle they were given in that first image that I showed you. I'm going to show you how we get those coordinates using special right triangles. And you may recall from geometry, special right triangles are those 45, 45, 90 triangles and those 30, 60, 90 triangles. We're going to talk about how the sides are related. Let's first look at this 45, 45, 90 triangle. In this 45, 45, 90 triangle, I'm going to give the length of the hypotenuse a length of 1 unit. Okay, so what we're talking about today, this hypotenuse, which we'll call C, is 1 unit. In a 45, 45, 90 triangle, it's an isosceles triangle, which means the lengths of the legs are the same. They are congruent. They have the same length, at which I'm going to give them the same variable, which is going to be the letter A. Okay, so I'm just showing you that because they're the same length, I'm going to show them to have a length of A. Using the Pythagorean theorem, which you may recall is a squared plus b squared equals c squared, in this case, because the lengths of the legs are the same, I gave them the same variable, so my equation is going to look like this. A squared plus a squared equals c squared. C is 1, so that's equals 1 squared. And now I'm just going to simplify this by combining like terms to get 2a squared equals 1. I'm going to divide both sides by 2 to get a squared equals 1/2. So again, I'm just solving for the value of a. And if you need to pause this video because you're taking notes, you need to pause the video, please feel free to do so. Rewind the video if you need to, or pause it if you need to catch up. So now I need to get a all by itself, which means I need to take the square root of both sides. When I take the square root of 1/2, I get the square root of 1 over the square root of 2. I need to rationalize the denominator because I don't want a radical in my denominator. How do I do that? I multiply both the numerator and the denominator by the square root of 2. When I do this, I'm left with the square root of 2 over 2, which means the length of each leg is the square root of 2 over 2. So now I have the length of every side of this special right triangle. Let's look at this particular angle, 45 degrees, this interior angle of 45 degrees. You may recall in the previous lesson when we talked about trig functions, sine, cosine, and tangent. And we reviewed SOHCAHTOA, which you also may remember from geometry, SOHCAHTOA. It tells us the ratio of the lengths of the triangle, right? The sine is the ratio of the opposite side to the hypotenuse. The cosine is the adjacent side to the hypotenuse, and the tangent is the opposite side to the adjacent. So what would I be looking at if I wanted to find the sine of this angle right here, sine of 45? Well, first, let's call this leg at the bottom, this horizontal leg, we'll call it x, and this vertical leg, we'll call it y. And if I want to find the sine of this angle, I'm looking at the opposite side compared to the hypotenuse. So the sine of 45 is going to be the opposite side, which is y, that's what I've shown it as, over 1. That means the sine of 45, or sine 45, is just y, which means sine 45 is the square root of 2 over 2. And I could have a little degree measure right there also, sine 45 degrees, which I don't. So the sine of this interior angle right here is the length of the opposite side. And I don't have to write it as a fraction because my hypotenuse is 1. So it's just the square root of 2 over 2. Now let's look at the cosine of this angle. The cosine is the relationship, or is the ratio of the adjacent side, that's the side next to the angle, to the hypotenuse, which means the cosine of 45 degrees is going to be x over 1, which is just x, right? Anything divided by 1 is just itself. So the cosine of 45 degrees is going to be just x, which is the square root of 2 over 2. So I have the sine of this interior angle to be the y value, or the opposite side, which is square root of 2 over 2, and the cosine of 45 degrees to also be the square root of 2 over 2. So now let's go back to our unit circle here. We've got our circle, we've got our axes drawn. What I'm going to do is I'm going to show you the coordinates, the 4 coordinates on each side, right? So from my center point, if I go out to the right, I'm at 1, 0, right? I've gone 1 unit to the right, 0 units up. If I go left, I've gone 1 unit left, 0 units up. So that's how I get that ordered pair. And then down here, 0 units horizontally, but I went down 1 unit. So 0, -1. Up here, we get 0, 1. What I'm going to do now is place that 45, 45, 90 triangle on this unit circle. And here, instead of calling this the hypotenuse C, we'll call it R, which means the length of the radius is 1. The length of this hypotenuse is 1. So you may recall that the length of, I'm putting this blue line here, you may recall from the previous slide, represented the sine of this angle, this interior angle right here, and this purple line represented the cosine of this interior angle. So I've got the lengths of this of the legs of this 45, 45, 90 triangle. We know the hypotenuse is 1, and we figured out when we reviewed this special right triangle that the length of this leg is the square root of 2 over 2, and the length of this leg is also the square root of 2 over 2. So how do I get the ordered pair that represents this point up here on this unit circle? Well, I can write an ordered pair using x, y, right? I'm going to go right this many units and up this many units. I'm going to go right the square root of 2 over 2 units and up the square root of 2 over 2 units. And that's how I get that ordered pair right there. If I place, and I've got that right there, the cosine was the purple and the sine of that interior angle right there represented the blue line, right? It was the y value. So the cosine was the x value and the sine was the y value for this interior angle. Now, if I rotate that special right triangle another 45 degrees, 45 plus 45 is 90, and now the length of that hypotenuse is 1, and there it is right there. That's how I get 0, 1 up here. If I rotate it again, I went backwards. Sorry about that. If I rotate it again, this 45, 45, and 45, I'm at 135 degrees total. But now I am moving this many units to the left and this many units up, which means I am moving left negative square root of 2 over 2 units, up square root of 2 over 2 units. So notice that in this second quadrant over here, I have the same values for x and y, but the x value is negative because I'm moving left. And then here I've rotated it again. The hypotenuse is the length of that radius right there. And then if I rotate it again, I'm going left square root of 2 over 2 units and down square root of 2 over 2 units, which is negative, negative, right? So all these coordinates are the same for these 45-degree angle measures. And then if I go down, I'm at a total of 270 degrees all the way around, and I'm at 0, negative 1. When I place another one on here, I'm almost all the way around, and this ordered pair is going to be the square root of 2 over 2, comma, negative square root of 2 over 2. So you can see how all of these are related. Okay, so there's when we've placed our 45, 45, 90 triangles on our unit circle. That is how when we break this out in our 45-degree angle measures, we get these coordinates right here. Okay, and they're all the same. It's just in the first quadrant, they're both positive. Quadrant 2, only x is negative. Quadrant 3, both are negative. Quadrant 4, your y value is negative. So here's what we got. Let's move on and let's review this 30, 60, 90 triangle. So again, I'm going to give the hypotenuse a length of 1. And in our 30, 60, 90 triangle, I'm giving the lengths of the legs different variables because they're not the same length. So we'll call this one A and we'll call this one B. And in a 30, 60, 90 triangle, how the sides are related, the hypotenuse is twice the length of the shorter leg. That's right here, and it's next to the 60-degree angle, okay? So it's twice the length of the shorter leg. So if we call this x, then we'll call our hypotenuse 2x, okay? And I'm just giving it another variable. I should have called it b and 2b, but I said x and 2x. Okay, so we know that because the hypotenuse is twice the length of the shorter leg, then we know the shorter leg is half the length of the hypotenuse. If the hypotenuse has a length of 1, what would be the length of the shorter leg? It would be half that, which is 1/2. So the length of B is 1/2. So now how do we find the length of this leg down here, A? Well, the length of the longer leg of the triangle equals the length of the shorter leg times the square root of 3, which means the length of this leg is going to be the value of B times the square root of 3. So this is how all of the lengths of the 30, 60, 90 triangle are related. It's x square root of 3, 2x, or you'll see x, 2x, x square root of 3. Which means if I want to find the length of A, I'm going to have to take the length of this leg and multiply it by the square root of 3. 1/2 times the square root of 3 is just the square root of 3 over 2, which means the length of this leg is the square root of 3 over 2. So now let's look at this 30-degree angle measure right here. And I'm going to talk about the sine of this 30-degree angle measure. Remember, SOHCAHTOA, sine is the ratio of the opposite over the hypotenuse, which means I've got the sine of 30 to be x over 2x, which simplifies to 1/2, okay? It's just basically I probably want a roundabout way of saying this, but the sine of this angle measure is the opposite side, right? And I know it's just that length because the hypotenuse is 1, right? So 1/2 divided by 1 is just 1/2. And the cosine of this would be the length of this side, right? It's x square root of 3 over 2x. There's my ratio. That simplifies to the square root of 3 over 2. So it's just the length of that leg, the cosine. And now let's move on to this angle measure over here. I didn't rotate this triangle. I just moved this little red arc right here to show you that I'm referencing this angle measure. So now if I'm wanting to find the sine of 60 degrees, the opposite side would be the square root of 3 over 2. So the sine of 60 is going to be the square root of 3 over 2, and the cosine of 60 is going to be 1/2. Okay, so that's how we kind of have to think about it, right? The lengths of the legs of these special right triangles. So now I've got my unit circle here. I'm going to draw my axes, and I'm going to place these coordinates on here that we know so well, right? Going out in either direction on our axes. And I'm going to place this 30, 60, 90 triangle on the coordinate on this unit circle with a 30-degree angle being my interior angle right here. We know the hypotenuse is the radius in this case, so the hypotenuse, which is the radius, is 1 unit. We also know that the length of this side over here, the cosine of 30 degrees is the square root of 3 over 2, and the sine of 60 degrees is 1/2. And we found that on the previous slide looking at this. If I'm going to write this as an ordered pair, from my origin, I'm going to go out square root of 3 over 2 and up 1/2. So the point on the unit circle right here is square root of 3 over 2, comma 1/2. Now what I'm going to do is switch it up a little bit, and I didn't necessarily rotate it, but I moved it around so that the interior angle right here is now 60 degrees. So I've added another 30 degrees to this interior angle measure. But what I moved it like this because I wanted to show you that now the length of this, the cosine of 60 degrees is 1/2, and the sine of 60 degrees is the square root of 3 over 2. So I changed it in this respect to show you that these values flipped. And now from my origin, I'm moving right 1/2 and up the square root of 3 over 2. So my ordered pair is going to look like this. My x and y values have switched because of this. And now if we move over to quadrant 2, I've just kind of taken these triangles and I've flipped them across the y-axis. So I could show you that if I added, I have my 90-degree angle measure. If I added 30 more degrees, and then if I added 30 more degrees, I'd be right here. That total is 120 degrees. How do I get to this ordered pair up here? I'm going to go out to the left 1/2 and up the square root of 3 over 2. And we know that in our second quadrant, only the x value is positive. And then this point right here, I'm going to go out to the left, the square root of 3 over 2, and up 1/2. And that's how we get this ordered pair right here. So as you can see, these ordered pairs look very similar, but my x value is negative over here. These ordered pairs look very similar, but my x value is negative over here. And now what I'm going to do is I'm going to, if I didn't actually put this on the coordinate plane, but if I took those and reflected them down, you can see that the ordered pair, like if I added another 30 degrees here and another 30 degrees here, we would see that these ordered pairs are the same and these ordered pairs are the same. However, both the x and y values are negative in this third quadrant. And then if I look in my fourth quadrant here, and let's say I've reflected either across the y-axis or down across the x-axis, whatever, you can see that these all in pink are the same and the green are the same, except in this fourth quadrant, only the y value is negative, right? My x value is positive and my y value is negative. So that's how those coordinates come to be when we look at our 30, 60, 90 triangles, which is what we use when we count by 30s on the coordinate plane. So now let's put it all together. This is what it all looks like. Only the degrees are shown on here. I've only got the degree measures because that tends to be what students understand a little better when we're first talking about the unit circle. So we've got our 360 degrees total right here. We've broken down our degree measures in increments of 45 degrees, okay, and increments of 30 degrees, all right? And then I've showed you how we get all of these ordered pairs. We first looked at the 45, 45, 90 triangles, and then we looked at the 30, 60, 90 triangles. And I've got it color coordinated so you can see how the ordered pairs are related. So let's first, I just wanted to take some stuff off here so there's not so much on the screen because that can get a little confusing. Obviously, if this is the first time you've seen the unit circle. So I've only got my 45 degree angle increments on here. And now let's look at our radian measures. So halfway around this circle, in radians is what? In degrees it's 180, in radians it's pi, which means the full way around is 2 pi. And that means if we count up, we've got pi over 4, pi over 2, that's 2 pi over 4, which simplifies pi over 2. Here's 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4 here, 6 pi over 4 simplifies to 3 pi over 2, 7 pi over 4 is 315 degrees, and then we've got 2 pi. So that's those radian measures on the coordinate plane now, so we've added some radian measures. So now let's look at our increments of 30 degrees. We have the 30 degrees and the 60 degrees here. So we're counting by 30s now when we're talking about radians. And again, right here, if I go halfway around, I get pi. All the way around, I get 2 pi. Now let's count by radians. Remember, half the circle has been split into 6. So we're going to count up pi over 6. 2 pi over 6 is pi over 3, right? Pi over 2. 2 pi over 3, 5 pi over 6, and 6 pi over 6 is pi. 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6 is 3 pi over 2, 10 pi over 6 is 5 pi over 3, and then we've got 11 pi over 6. So now I'm going to add, and let me go back. Sorry about that. So now we're going to put all of these radian measures on our unit circle. So we broke it down into the fourths, right? The pi over 4, 3 pi over 4, or at least half the circle, right? The whole circle was divided into eighths. And then we did our 30-degree angle measures, and we got this. And this is our unit circle with all of our degree measures, our radian measures, and our coordinates shown. I know it was a lot. If you struggled with the why this came to be, memorize it, okay? Memorize that, okay, square root of 3 over 2 and 1/2. If I've got that, I know over this way is negative x value, this way is negative x and y, this is only a negative y. And then up here, these values are those values switched. If you can at least name the coordinates in this first quadrant right here, you can remember the pattern, memorize the pattern to label the rest of this, okay? So now let's talk about when we talked about degree measures, or the sine, cosine, and tangent, these trig functions. The sine of this 30-degree angle measure right here is the y value, right? It was the length of the opposite side to the hypotenuse, which the length of the opposite side is our vertical change, which is positive 1/2. So the sine of 45 degrees is going to be the square root of 2 over 2. The sine of 60 degrees is going to be the square root of 3 over 2. So if you see sine of a degree measure or sine of an angle measure right next to, in place of theta, then your answer is going to be the y value. So the sine is all of the y values. Sine of each of these angle measures is going to be the y values. All right. And now let's move on to the next little bit, which is cosine. When I talk about cosine theta, or cosine of an angle, we're looking at the x value. So if I'm wanting to find the cosine 30 degrees, remember that was the distance that we moved to the horizontal distance, and that was the length of that longer leg in that 30-degree angle, which was the square root of 3 over 2. Cosine of 45 degrees is going to be the square root of 2 over 2. Cosine of 60 degrees is 1/2. So the sine theta is the value of y, and when we're looking at the coordinates, and the cosine theta is the value of x. Cosine of 90 is 0. Cosine of 120, here we go, and it's all the x values. These are our cosine values, right? Our trig functions of these general angles that are included on this unit circle. So now let's move on to tangent. Tangent theta, recall when we talked about SOHCAHTOA, tangent was the ratio of the opposite side to the adjacent side. So you can't just look at your unit circle and say, oh, there's the tangent, right? There's tangent theta. You actually have to do a little math. If it's the opposite, if the tangent of an interior angle is the ratio of the opposite side, which is the sine value, over the adjacent side, which is the cosine value, then you're going to take the y-coordinate and divide it by the x-coordinate. So let's say I want to find tangent 30 degrees. I know that tangent of 30 degrees, the opposite side is 1/2, or the y value is 1/2. I'm going to divide that by the x value, which to be the square root of 3 over 2. So let's show how we break this out. How do we do 1/2 divided by the square root of 3 over 2? Well, that's equal to 1/2 times, I'm going to flip it, and then I can simplify to get 1 over the square root of 3, and then I rationalize the denominator to get the square root of 3 over 3. So I got to do a little bit of math, but remember, how do we divide fractions? Keep, change, flip, multiply across, and then don't forget to rationalize the denominator. So how do we find trigonometric values of general angles? Well, let's look at our unit circle here. I've got everything shown on the unit circle. For this first assignment, you'll want to reference your unit circle quite a bit. I've got our, sine theta is y, cosine is x, and tangent is y over x. So how do I find the sine of 45 degrees? 45 degrees is right here. Sine is our y value, which is the square root of 2 over 2. Cosine of 150. Cosine of 150, that's all the way over here. Cosine is our x value, which is the negative square root of 3 over 2, which is our answer. Cosine of 150 is negative square root of 3 over 2. Now, sine of negative 30, remember, these negative angles, we move clockwise. So sine of negative 30 is actually coterminal with our 330-degree angle right here, which means sine of 30 is right here, and that's going to be negative 1/2. Now let's look at sine 3 pi over 4. So now we're looking at a radian measure, which if you're ever using your calculator for anything, and I'll do this in the next lessons, but you want to make sure that you're in the correct mode. Are you talking about radians, or are you talking about degrees? So sine 3 pi over 4 is right here. It's this angle measure right here. It's the same thing as 135 degrees. Sine is the y value, which is the square root of 2 over 2. So this is our angle measure. Sine is the y value. We've got the square root of 2 over 2. Let's move on to the last 4 problems on this set of notes. In this case, we've got cosine 7 pi over 4 minus pi over 2. Okay, well, I need to simplify this. The first thing I need to do is get a common denominator. So 7 pi over 4 minus 2 pi over 4. I just got a common denominator. And when I subtract that, I get 5 pi over 4. So I'm really looking for the cosine of 5 pi over 4, which is right here. Here's 5 pi over 4, all the way around this way. Cosine is our x value, which is negative square root of 2 over 2. Now let's look at tangent 300. Well, here's 300 degrees right here. The tangent is going to be the opposite side over the adjacent. So y over x, right? So negative square root of 3 divided by 1/2. When I show that out, negative square root of 3 divided by 1/2, I'm going to keep, change, flip, and then I'm going to cross out those, and I get the negative square root of 3, and that's my answer. Okay, so I'm just multiplying fractions, and I know that I did that kind of fast because I can't expect you to know how to do this at that point. Tangent of 90 degrees. We're looking at our 90 degrees up here, which is y over x, 1 divided by 0, which is undefined. Can we have 0 in the denominator? We cannot. If you had 0 divided by 1, that would be 0, but 0 cannot be in the denominator that is undefined. Now let's look at our very last one, which is tangent 11 pi over 6. So where is that? Tangent 11 pi over 6 is right here. We're looking at y divided by x, negative 1/2 divided by the square root of 3 over 2. Looks like this. Divided by the square root of 3 over 2. I'm going to keep, change, flip, and then I'm going to cross out the 2's. And then I cannot leave it like this. Negative 1 over the square root of 3, I need to rationalize the denominator. So I get negative square root of 3 over 3. And that's my answer. And that concludes your notes over the unit circle. We did some trig functions of general angles. That's what we call this. These are general angles. They're included on the coordinate plane. We didn't do any kind of like funky angles or anything. So we did trig functions of these general angles, and we looked at the unit circle. We built it. We looked at the why, the how it came to be. And that concludes your notes. I hope it was helpful.